Hello, students. Good morning. Hi. Okay, welcome to another lesson. Okay, today it's a continuation. Today's lesson is a continuation of the lesson that we had on Saturday. Okay, this is Threats to the Environment, Part 2. Okay, so Saturday we had Part 1. I wanted to break it up to 2 parts because it's a little bit long, so I didn't want to drag it for more than 1 hour. Okay, so I hope you can hear me. Let me check the comments here. Good morning, Jiawei. Good morning, Min Yin, sorry. Tiet Yi, Kersin, Xin Hui, everyone, good morning. Can you hear me? Okay, is my audio here loud and clear? And let me share screen. Can hear. All right, Jiawei, thanks for the feedback. Angela, good morning. Okay, are you able to see the screen? Okay, I've put here my PowerPoint, my OneNote, and I'm showing air pollution here. Yes, okay, good. Thank you very much, Ning. Thanks, Yin. All right, so I'll jump straight to the lesson now. Okay, so as you remember, let's recall what are the 5 components, 5 threats to the environment. So we had mentioned already 3 of them actually. So let's just recap. We go up here. We have mentioned actually Saturday. Our whole lesson here on 1 is on the threats of an environment. So what are the threats to the environment? Threats to the environment, sorry, not off. Threats to the environment. Okay, sorry, just went off a bit. Okay, here. You have 5 here. So I've covered climate change, deforestation, loss of biodiversity, and eutrophication on Saturday. Okay, so now I'm left with the last 2 here, which is pollution and also threat human population growth explosion, okay, which I will cover today. So our lesson shouldn't be very long. It shouldn't last more than 1 hour. All right, let's look at the last part, last 2 sections here. All right, let's start with pollution. Okay, pollution is a very common issue. You've seen it in your BM lesson, okay, pencemaran. You also learn it in your English lessons because it is across the curriculum. A lot of subjects also touch on pollution because we want to create an awareness in the young generation that our earth is actually very much polluted, and the only thing we need to do is to correct the problem. Okay, so all right, let me just have a look at here. Now, pollution, what is the definition of pollution first? Pollution is an undesirable change. That means it's a change that you do not want. It is not good. Something that is undesirable is not good. Desirable means you want, something you want. Undesirable is something that you want. Okay. It's a change which is undesirable. In what aspect? In the chemical aspect, that means the chemical composition of the air, of the water has changed. Or the physical, meaning the components, what are inside the air, what is inside the water, okay? And the biological aspect of the nature. So all this would have changed, and it changed for the worse. Okay, so chemical composition, the physical aspect, and also the biological characteristic of nature. That includes the plants and the animals. Okay, so here the flora, the fauna, and also the abiotic component, meaning the environment. Okay, so everything is included in here. So pollution affects the soil, the rivers, the seas, and the atmosphere. It threatens the life of humans, animals, and plants. So it threatens all the living things. So it's basically a change in the abiotic factors, but abiotic factor will affect the biotic factor. Okay, so I will clarify this by saying, usually when we want to talk about pollution, is the changes in the abiotic factors, and this is found to be able to affect the what they call affect the lifestyle of the factors. Okay, so pollutant. Now, what's a pollutant? Pollutant is a substance. So do not interchange your word now. Pollution is not pollutant. Pollution is a phenomenon. That means the thing that happens is a thing that happens. But pollutant is the thing that makes the pollution. So pollutant can be the gas, poisonous gases. It can also be substances which are suspended in the air. So these are the things. Pollutants are the things or the substances that can make pollution happen. Okay, so they are present in excessive amounts as a result of human activities. So all we have, usually what causes pollution is human activities. If you leave nature to itself without any human intervention, you will find that there is very little pollution. And somehow nature has a way of correcting itself. But when you have human intervention, when you have too much activity, and humans usually they will produce a lot of waste, so that overpowers the natural healing process of the earth. Okay, now here there are 4 types of pollution. So I want you to remember this. There are 4 different aspects when it comes to pollution. So to make it easy to remember, let's remember the acronym WANT. Okay, want. W for water, A for air pollution, N for noise, T for thermal. So you have 4 types of pollution. So we look at one by one. So usually for this kind of questions, they will ask you for cause and effect. Kesan dan akibat. What is the cause and what is the effect? Okay, what's the difference here? Cause is what causes it to happen. What are the things that is the sebab? Why does it happen? Okay, the reasons why it happens. What makes it happen? And then the effect is the kesan. What happens if this happens? What happens when you have air pollution? You will have the human health will deteriorate. Okay, you have respiratory problems. That is called the effect. Effect is what is the akibat? Kesan or akibat. Okay. So you normally talk about the cause first, and then you talk about the effect. Okay, because it's logical. Because you have the cause, then you have the effect. It's not the other way around. Okay, let's look at air pollution. Air pollution is caused by the presence of pollutants. Okay, definitely because pollutants. Okay, okay, right. So pollutants, what are the pollutants here? They can include smoke. In fact, smoke is a general term for all the particles which are released into the air and the gases. So smoke can particles added with gases. So it's a general name. Dirt is definitely particles only. Dust is also particles. That means it's matter. Okay, and then you have also another which pollutes the environment. So they are harmful. First of all, so you do these things that pollute the environment. So we talk about the source, all forms of burning or combustion. So when you have burning rubbish and also forest open burning, whether it's intentionally or unintentionally, as long as you burn something, there will be carbon in the substance. There's carbon in the paper that you burn. There's carbon in the trees. There's carbon in the leaves. So when you add carbon when you burn, it combines with oxygen, you will get carbon dioxide release. That's why you have always carbon dioxide emission when there's combustion. And if it happens in a condition where it's less oxygen or lack of oxygen, you will have, okay, you will have carbon monoxide. Now, this is more toxic in the sense that it causes carbon monoxide poisoning. So when there's lack of oxygen in burning, you will form carbon monoxide instead. When you have adequate, that means enough oxygen, you will form more carbon dioxide. Okay, so if we talk about greenhouse gases, this is carbon dioxide is a greenhouse gas. Okay, carbon monoxide is not a greenhouse gas. Okay, so this is more of a pollutant. This is a pollutant. Okay, this is a greenhouse gas. Usually carbon dioxide is not considered a pollutant. Okay, so it's a greenhouse gas. All right, now let's look at what you get when you burn rubbish. You will get carbon dioxide, you will get dust, you get soot, you get smoke. Okay, combustion of fossil fuel in factories and in industries. Combustion of fossil fuel, coal, natural gas, and all the products of petroleum, meaning diesel, petrol, kerosene, all these come from petroleum. They will cause also pollutants. Actually, you also have carbon dioxide. Okay, you may have carbon monoxide also because of lack of oxygen. And if your fossil fuel has sulfur inside there, sulfur elements and also nitrogen elements, when you heat up and you burn your fossil fuel, you will also get sulfur dioxide and nitrogen dioxide. Okay, so these are the other, because you have elements of sulfur and nitrogen inside your fossil fuel, then you will have that as well. Okay, next. Motor vehicles that release exhaust fume. Exhaust comes from combustion of petrol inside the engine. So you also have, because of combustion, right? You have carbon monoxide, lead, and also soot is the black thing that comes in the smoke. It's because of carbon actually. Soot is because of carbon. Okay, agriculture through the use of agrochemicals. That means chemicals in agriculture. You have fertilizers, pesticides, insecticides, herbicides. So all these slight differences in the sense of meaning. You see all the sides here, CIDS, CIDS. When you talk about sides, this is a suffix, is the word I put at the back to indicate that it's. So you have seen the word suicide. What does it mean by suicide? Someone who commits suicide is someone who kills himself. Side is killing. Okay. Then you have homicide. Homicide means you kill other people. So you have a pembunuhan. Case pembunuhan is called homicide. That means killing a man. Homo is man. Okay. So pesticide is killing of pests. Pests could mean rats. It could mean the grasshoppers. Things that destroy your, they are called pests. Things that eat up your tanaman. Okay. Then insecticides. These are chemicals which kill specifically only insects. So like maybe bugs, okay, and insect, a grasshopper that eats your plant, the leaves, and also caterpillar and so on. Yeah, under insects. And herbicides. These are substances. The slide still shows page. Okay, sorry, what does that mean now? Wait, I'm actually showing pollution here. The first page. Do you see the screen is not changing? Oh, okay, okay. Do you see? Let me share. Stop sharing and I'll share again. Right. Okay, let me share again. Share screen. Yeah, please do tell me whether there are problems. All right. Do you see this picture of a factory producing smoke and all that? Do you see this? If you can see this, that means you're on the next page already, because the first page was not showing this picture. Okay, is that okay now? A bit lagging, because of lagging. Okay. But are you able to hear me? Can you hear me well enough? Yes, you can hear. All right, you can hear, then it's fine. I think mostly it's more of the audio that's important. This one I can give you the worksheet for you to fill in later. Okay, now let's go on to this one. Let's come back to this one. Herbicide are those chemicals which they kill herbs. Herbs means plants. So they kill all these unwanted plants that will compete with your plant to get the nutrient. So they actually kills the, what you call the 野草. 野草 is all the lalang, the grass that you don't want. Okay, why you want to kill it? Because if you don't kill the lalang, you don't kill the grass, they will compete with your plant for the nutrients. Okay, so herbicide specifically is to kill the herbs or plants. Okay, let me switch on my charger for 1 minute. Okay, now let's look at what happens when these gases dissolve in water. So when you have carbon dioxide, sulfur dioxide, and nitrogen oxides, why do we call it nitrogen oxides? Because there are two types. One is nitrogen oxide, monoxide, and the other one is nitrogen dioxide. It's NO and NO2. Okay, so that's why we call it nitrogen oxides. So now it's okay, yeah? Yes, can hear. All right, now you can see better. I think it was stuck there. Okay, so thanks for the feedback. So when you talk about all these pollutants or gases which are harmful to the environment, when you release it to the air, they will actually dissolve in the rainwater or dissolve in the water vapor. So when they dissolve, they form acid. So they are acidic. Okay, now all these equation you don't need to remember. In biology, you are not needed to write it in the equation in the kind of chemical symbols and also balance it. You leave that for your chemistry. What we need is the name for biology. Okay, so if you forget how to write the formula for certain substances, don't worry about it. You just write it in words. Okay, so nitrogen monoxide is NO, nitrogen dioxide is NO2. So when it dissolves in water, you'll find that it forms nitrous acid. If NO, it forms an HNO2. If NO2, which is nitrogen dioxide, when it dissolves into water, it forms nitric acid. So that's why you can have two types here. For carbon dioxide, when it dissolves in water, you get carbonic acid. Okay, you learned that in last year, chapter 9, chapter 8, when you talk about the transport of carbon dioxide in the plasma. Okay, CO2 dissolves inside with water, you get carbonic acid. And for sulfur dioxide, okay, when it dissolves in water, you get sulfuric acid. So whatever you see, however you see, is always acid because these gases are acidic. Okay, so what happens is you're going to get acid rain. Okay, when these substances, that means the substances dissolve in the rainwater or in the rain, not rainwater, sorry, in the water vapor, you are going to get acidic substances. So they will drop back to the ground, and that's where you have your acid rain phenomenon. Okay, the pH of acid rain will be stronger than or less than 5. Okay, 5, usually rainwater is 5.6. But if you have acid rain, it should be lower because as you remember, the lower the pH, the stronger the acid. Okay, so it will be less than 5. And what is the effect? Later on, you'll see the effect of acid rain to the environment. Okay, first of all, you see this diagram is very helpful for you to remember. You need to remember sulfur dioxide, nitrogen monoxide, and nitrogen dioxide. When it dissolves in rainwater, sulfur dioxide forms sulfuric acid. Nitrogen dioxide dissolves in rainwater or rainwater vapor, you get nitric acid. Correct. Dioxide, you get nitric acid. Monoxide, you get nitrous acid. Whatever it is, all these three are considered the culprits of forming your acid rain. So these are the things that form your acid rain. Remember the name. So you have to remember the gas and the formation of acid rain. How? You just remember this. Dissolve in water vapor in the clouds, in the atmosphere to form the acid. Okay, let's look at the effect of acid rain. So because acid is corrosive, okay, you know the properties of acid, right? It's corrosive. So you will find that it affects certain structures. It's corrosive when it comes to contact with metals. Metal will be corroded. Metal is corroded, all right, when it comes into contact with acid. So you learned that already before in even lower form 2 science. Okay, metal is corroded when you have acid. So this also is the reason why when people who stay very near the sea, like Penang and all that, they find that metal structures, they actually corrode quite easily, okay, because of the contact with the salt, okay, that comes from the sea, from the wind. So if you have a metal structure and you put into seawater, it corrodes very much faster compared to if you put in distilled water. Because metals, okay, you have acid there. You also have salt. Acid and salt also will promote rusting. Okay. Now, next one, soil will turn acidic when it drops onto the soil. When the acid rain drops onto the soil, it will acid. Okay, it will become acidic, and it will not be suitable for plants because certain plants will have different tolerance to acid soil. And when the acid goes into the lake or the water source, river and lake, they turn acidic, and the plant, the animals may also be, or they can even die when it becomes too acidic. They also have a tolerance to acid. And toxic metals such as mercury, this is heavy metal, mercury, nickel, cadmium, all these, they leach, means they run into the river, and these are heavily deposited in the river. So you have the of acid rain. What about let's look at air pollution. That was just now is what okay, this is just air pollution. The effect first. Now let's look at the effect on human health. There are many aspects. Okay, the effect on human health. So as you know, you learned it earlier in Form 3, when you breathe in all these gases, it becomes actually irritating. These gases, they irritate your eyes, they cause skin diseases, they also cause conjunctivitis. Conjunctivitis is the inflammation of the layer called conjunctiva, the outermost layer of your eye. It protects your cornea actually. So you have red eye. So red eye is one reason is you could be having conjunctivitis. That means something inflammation layer called conjunctiva. Okay, so this can also be brought about because of in the air. So the air and the smoke causes to become red. Okay, now it causes respiratory diseases. So the examples of respiratory diseases are bronchitis, asthma, okay, breathless are the symptoms. You cannot breathe because the breathing tube, or we call the bronchus, bronchiole, they have already been inflamed. That means we call it inflammation. That means it bengkak, then the locus inside there, and the lung becomes narrow. So it's difficult for air to move through. Okay, so when air goes in very little, you may be breathing hard. That's why you need to breathe harder because you need to suck in more air. So the air is very difficult because the lumen is very narrow. Okay, so it also causes emphysema. Okay, look at emphysema, where the air walls will collapse and join with each other. That means becomes less surface area. Okay, it causes difficulty in breathing and coughing. Okay, let's show you what it means by emphysema. This is a revision. You've seen it in Form 3. Okay. Okay, sorry, I just went off. Where is my picture? Yes. Sometimes it's not so stable. I don't know what's happening to the OneNote nowadays. Okay, let's look at some pictures. Here. This the picture on the left here is normal alveoli. This is healthy. When it's healthy, you notice that the structure, okay, they are more or less, all of them are perfect. Yes. I mean, they are not perfect, they are all, the membrane here is complete. You have this air sac alveolus. Okay, they are not damaged in any form. So you have, because you have it intact, so you find that surface, when you add up all the surfaces, you have total surface area which is high because you don't have any broken surfaces. Okay, you don't have any broken surfaces. But emphysema is a condition where you will have the surfaces inside here are much less. So for example, if I were to draw, okay, here, this is the same thing, right? Let's say this is here. But this is smoking also emphysema. Because when you breathe in the smoke here, it also acidic substances. It's because of corrosion. Okay, the acid in the cigarette smoke or the acid in the smoke that you breathe in, acid there. So what happens is, okay, let me just erase some here. Because of corrosion, this part of the membrane is broken down. So you find that the surface, the surface decreases. Okay, right. You see the surfaces? The surface decreases and you find it's not so complete. Each one of the alveolus or the alveoli sac is not that complete. So when you take into account the surface area is definitely much lower. Okay, so I'll write TSA, total surface area decreases. You have edema. Now, why is it affecting you in breathing? Because diffusion of gases is dependent on surface area. The more surface have, the higher the rate of diffusion of the gases. So when you have more surface, that means it's very good. The gases are able to go in and out faster, more, okay, at a higher rate. But when your diffusion is, when you have less surface area, you have less diffusion. So the rate of diffusion of oxygen going out, carbon dioxide coming in, all this will be less. Therefore, the person can be breathing, but difficulty in getting enough oxygen. You'll find breathlessness. Okay, so you can see another picture here is, you see the internal part here is all circles there, all the alveolar spheres, but here you can see them have already joined up. So this is okay, but when you have the broken surface that it joins up, you see the middle partition is gone, okay, because it has already corroded or eroded. So you have a less surface area. Okay, this is look here, emphysema. You have surface area, the alveolar membranes break down, and this is the healthy one, the one in the middle. Now pneumonia is actually infection of the lungs. Okay, this is due to bacterial infection. So pneumonia is usually not much because of smoke that you inhale or the gases that corrode it. It's because of bacterial infection. Of course, when you breathe in the dirty air, there could be bacteria there. So you have infection of the lungs, then there will be fluid and blood cells in the alveoli. So this one can be treated by using antibiotics. Okay, so this is usually due to microorganisms. So this is an infection of the lungs. Okay, so here I hope it's quite clear you have an understanding of emphysema. So make sure this is emphysema can be brought about through cigarette smoke also. Cigarette smoke contains it as well. So let's look at this one. It just jumped again. All right, let's go back to here. Let's go back to the next form of pollution. Sorry, you're still at air pollution, but we look at animals and plants. How does it affect? Okay, acid increases the acidity of the soil. Okay, that you know already. And when the acidity increases, it also causes the essential nutrients that are in the soil to be leached. Leach means it runs away. It runs into the in other parts. For example, it runs the rivers into the lakes. That means it's called depleted. Depletes become less. Okay, or nutrients here will become less in the soil. So that is not a good thing. All right, leaching of essential nutrients. Example, potassium and magnesium, nitrogen, all that. It causes to be infertile. That means not fertile. Okay, so leaching is not a good thing, right? Now, acid rain that falls into rivers and lake water, it will in turn endanger the life of fish because they cannot survive if the water is too acidic. Okay, so acidic soil also causes plants and trees to die. It destroys the leaves. Okay, it destroys the leaves. It also impairs, that means reduces synthesis because it destroys the chlorophyll in the leaves. Okay, so because it also changes the color of the leaves from green to purple. So it changes the color of the leaves, and when it changes the color of leaves, you find that it will not be so effective in sunlight because it usually if the blue and the red is most efficient of photosynthesis. So if your leaves become red or become purple, right, become blue, you find the absorption of the sun rays will be less, and that will cause less rate of photosynthesis. Okay, another thing, when you have this smoke, okay, your soot, all this, they can actually block the stomata. Stomata, that are those little pores, okay, on the surface of the leaves, which allow exchange of gases. So when you have something that blocking it, that means the gases cannot move in and out. So you also have a reduction in the rate of photosynthesis. So less photosynthesis. Okay, toxic chemicals can also cause the wildlife to migrate. For example, if you put certain chemical into the lake, you notice that the paramecium and the amoeba, they will run away, okay, because they run away from chemicals. Okay, so they have chemotaxis negative, so they run away from chemicals which are harmful to them. So they will migrate to another area, okay, migration. And birds with long-term exposure to pollution have been found to have reduced egg production, so they produce less eggs, and that causes them their rate of reproduction to decrease. Okay, on buildings, It also affects the infrastructure. Acid rain corrodes metal structures. It also dissolves limestone. Limestone is calcium carbonate. So when you have acid in contact with calcium carbonate, the carbonate actually will dissolve when you get acid to it. Okay, it dissolves in acid. So the structure becoming less sturdy, it may even drop altogether. So you have the buildings or the exterior, all these are changed. Okay, it can dissolve aluminium, copper, all these kinds of metals. And soot has an undesirable effect. It blackens the building because soot is black in color. So imagine you have a wall that is, you see some of the wall at the bottom there is all black. It's because when you use the gas from the stove, it's yellow flame and it produces a lot of soot. Okay, climate. So it forms haze, this smoke, dust and all that. When it combines in water vapor, it forms haze. And the haze is actually suspended particles. And you find everything is blur blur, right? You can't see very clearly through the haze because there are a lot of suspended particles in the air. Okay, and that also increases because of carbon dioxide. And increase in carbon dioxide can rise the temperature because it contributes to the greenhouse effect. Carbon dioxide is one of the greenhouse gases. Okay, and as you know, greenhouse gases, it traps the heat on the surface of the sun, of the earth, and then causes the earth, the polar ice cap will melt, causes an increase in the water level, and that causes floods in low-lying areas. Okay, agriculture. Okay, haze also prevents sunlight from reaching the earth's surface. Your haze is very blur, so you can't see through. On a clear day, you maybe can see 1 kilometer away, but for hazy days, you can only see a few hundred meters in front of you, maybe even only 200 meters in front of you. The rest is all blur blur. Okay, so when it will also block the stomata, it blocks, it reduces the rate of photosynthesis. As a result, your plant cannot produce as much food, and then your fruit production will be less. Okay, and less supply lah. All right. Okay. Now next one, let's go to air quality. Okay, next. So you like a good, everybody know this because sometimes we have pollution. Some years ago we have pollution. Everyone's encouraged to wear masks. So how do you know the air quality is good or not good? We have a measurement. We have an index called pollution index (API). Okay, how do you get API? It is obtained by measuring the fine particles that are suspended in the air. So they are so small. The size of the particle is below 10 micron. Okay, how much is a micron? 1 micron is 1 micrometer. Okay, I think I've already discussed this with you. Micrometer, how small is a micrometer? 1 micrometer is equivalent to, okay, let me look at this. 1 micrometer is actually 1 over a million of a meter. Okay, I'm sure you still cannot imagine how small is 1 of a million meter. So I will change it to 1 to 1,000 of a millimeter. So it's very simple. You take out your ruler. Okay, you want to know 1 micron or 1 micrometer is how small. You take out your ruler. You look at the smallest calibration here. The smallest here is 1 mm. Okay, 1 cm has got 10 mm, correct? 1 cm has got 10 mm. You look at the 1 mm there. You imagine you divide your 1 mm into 1,000 times. Okay, the small little 1 mm here, you go and divide 1,000 times. So if you divide 1,000 times, okay, the size, after you cut it into 1,000 times, 1 mm you cut into 1,000 times, 1,000 small partition, you divide by 1,000, that small little part will become 1 micrometer. So this is how small your micrometer is. And then for API, the particles they want to measure the size is 10 micron. Anything that's 10 micron below, okay, you take into account got how much in the air, and then you give a number. So if the number is very little, very small, your API is very small, for example, 0 to 50 or anywhere from 0 to 100, this is called good air, okay, quite good. That means the air is considered healthy. So look at the range here. Anything below 100 API is considered healthy. So you can go about your days. You can go about in the, you can go out without wearing your mask and so on. It's a good quality. It's a good air quality, okay? But anything above 100, you have to be careful. is start to consider as unhealthy. So 101 to 200 is unhealthy. You'll find slightly blurry the environment, the we call it visibility is a bit low, and then you may have to, you can smell, okay, when you go out and you smell the air, you can find some kind of burning smell or something like that, okay, and you may need to wear a mask. Above 200 to 300, this is very unhealthy. So last time we had until 300 something. That was in Sarawak somewhere when we had our haze that time. That was, I think, a couple of years ago. So below, above 100 is considered bad. 200 even worse. Above 300 is very unhealthy and very dangerous. So you have to wear your mask when you go out. What are precautionary steps? You need to drink more water, okay, so that your particles it's not in your throat, okay. It gives your what they call uncomfortable feeling when your particles are in your throat here. You have to stay indoors, try not to go outdoors if you don't have to, and you need to wear masks. So these are the things you can do. There's nothing much you can do actually. You just need to protect your own respiratory system. Okay, let's look at the next one. Thermal pollution. So we have seen water, we have seen air. Okay, now we look at thermal pollution. It's a release of excessive heat into the environment. You get this thermal pollution. What causes thermal pollution? Okay, what causes thermal pollution? It's because of the big culprit, actually these two. Number one is the discharge of hot water. Now, why do people throw hot water into the river, into the lake? It's usually because of factories. Factories, they process certain things. They have machinery. Okay, so sometimes machinery gets hot. You need to cool down certain things, certain parts of the machinery. And what they do is they use water from the river or from the lakes, whatever. They cool down the machine. And what happens when the water comes into contact with a hot substance or the metal or the machine? It actually absorbs heat. So water is very good in absorbing heat actually. It has a very high, we call the latent heat, okay, a specific heat, latent heat. So it's able to absorb a lot of heat. So now the heat is taken away from the machinery. That means it cools down the machine. But your effect is the water is now carrying the heat. So now the water is hot. So what do you do with the water? You throw it away, okay? Because if they want to recycle the water and cool it down, it requires another process of cooling it down. They will involve more energy using. So they want a simple way. They just take the water and you cool down the machine. Now the water becomes hot, they just throw it into the river, okay? And also, besides factory, you have reactor nuclear, and this is very important. They use huge amounts of water to cool down the reactor so that it does not become overheated. Once it becomes overheated, it will blow up, just like what happened in Chernobyl and also in Fukushima, okay, 2011. So because of the tsunami in Japan at that time, so this machinery, the cooling system was damaged by the sea, by the water that came in. So when the cooling system damaged, they could cool down properly. So the heat was building up. And building up, it built up until extreme proportions, it just blew up. Okay, so there was explosion and all the radioactive waste were spread into the environment. Don't know how many kilometers away, I think 50 kilometers within the radius. So all the plants and animals were exposed to radioactive these rays. So that is the reason why you need to make sure you have a steady supply of cold water when you have your nuclear power station. Okay, your electric power station, you also need that for cooling. Okay, now another culprit is glass building. Glass building, you usually have it in cities where a lot of these buildings are, you have the windows made of glass, right? And why are they using glass? Because it actually blocks out the heat from the sun. So interior, inside the building, no problem. Okay, look at this building here. Inside the building, no problem, right? It's cooling here. But the problem with glass is it actually reflects heat. Okay, so inside is cool, all right? That's what we want lah, because we do not, Malaysia here, in hot countries, you want the temperature to be cool because it's whole year round very hot. So you have glass, you find that is to block out the heat, but actually how does it do it? It reflects the heat away. It doesn't absorb the heat. So glass is a very, it does not absorb heat very well. Okay, so the reason here now the heat is being reflected back into the atmosphere, so the temperature rises. So usually in cities, when you have a lot of these glass buildings, okay, buildings made of glass, your temperature, there will be thermal pollution. The heat will increase. Okay, so here let's look at number 3. Electronic factories, electric power station, nuclear reactors, they use water as a cooling agent. Okay, so it has a high heat capacity. It can absorb heat very well. So as a result, the heat is now inside the water. The heat has been taken by the water, so water becomes hot. Hence, the hot water is then to reverse. Okay, it causes the temperature to increase. So why is it not good? Why is it not good? Why you don't throw back into the river? Because it's going to harm the aquatic plants and also the animals there. How? Number 1, okay, the aquatic animals can die because of the heat change. Okay, now even a change in the temperature about 5 to 10, it will actually affect the biomechanisms or all this process of the mechanism, biochemical processes of the aquatic organisms. That means your enzymes may not be working very well. Okay, for plants, your optimal temperature of water, actually in water, it should be around 26 to 28. It shouldn't be too hot. Okay, once it increases up to 10 degrees, yours and the animals will start to suffer. Okay, because this biochemical process, that means the enzymes do not work as well, and it also causes maybe hatching of the fish eggs. Okay, so it's their life cycle, or they may even be hatched. The eggs may even fail to hatch if they're too hot, or they may even hatch early. Okay, so another reason why is it bad for the water supply or the animals is because it increases the temperature rises, the bacteria here in the water, in the river here becomes more active because of temperature rise. Okay, so the decomposition happens very fast. When decomposition happens very fast, it will use up more oxygen because decomposition uses oxygen. So the bacteria is using up more and more oxygen, so it will increase the DOD. All right, the oxygen will drop. The concentration of oxygen will decrease. And when that happens, the fish and the prawns and all that will start to have less oxygen. They will die. Okay, that's number 2. Now, number 3, oxygen. When the temperature increases, the water is hotter, you find that actually oxygen becomes less soluble. It is less able to dissolve if it is hot compared to a body of water that is cooler. Okay, so there'll be less oxygen when the water is hot. So, and this is not good, right? Because that means your plants cannot dissolve. Cannot get from the air. The oxygen has to be inside the water in order for the animals and plants to use it. Okay, so concentration of oxygen is reduced. So you can see that this is the effect of having hot water. When the river supply or the river water or these lakes, the temperature rises. Number 1, it disrupts your biochemical processes of the aquatic aquatic life. Number 2, it increases the decomposition rate. And number 3, it reduces the solubility of water, of oxygen. Okay, it decreases the solubility of oxygen. Okay, now let's look at glass building. Now, glass building, they reflect. Okay, just I mentioned earlier, they reflect the sun. So inside is good, all well and good. Everybody cool inside, but they forget that actually heat is trapped in your environment. So the temperature, the global temperature increases. Usually this happens predominantly in cities. Okay, so you can see the temperature of water here, the correlation, the relationship between the dissolved oxygen and temperature of water. When the temperature rises, you see 40 degrees Celsius is very hot for water, for water that is in the river and the lake. You see that the oxygen, dissolved oxygen is very much lower. When the temperature is lower, let's say 20 something, all right, this is quite ideal. You find that the amount of dissolved oxygen is higher. And even if it's cooler, the dissolved oxygen is even higher. So you can see that it drops when the temperature becomes warmer, of the water becomes hotter. Okay, lastly, second last, that's another part. Noise pollution. Noise pollution, actually, it disturbs our concentration, it disturbs our mental health. Okay, some people cannot stand loud noise. When there's loud noise, they become very agitated, they become irritated, they can't think, they can't function well. So it's noise pollution is the occurrence of excessive noise in the environment, usually in the city, when you have traffic jams, people honk and there, okay, and machinery, okay, that constitute a lot of noise. In the country or in the kampong, you will have actually less noise pollution. Okay, so it's not so bad when you go to the countryside to live. How do you measure loudness of sound? You measure using a unit called decibel. Okay, decibel, small d, capital B. Okay, so what is considered a safe number or value for sound, noise? So when you have anything between 50 to 60, now this is considered safe lah. Usually this is our normal range of sound, because when we're talking to people, we don't shout, right? We're talking our normal range is about 50 to 60. That will be considered quite okay. But when you start shouting, be above 60, okay? Anything above 80, all right, it causes discomfort already, okay? So a lot of loud noise, maybe in a traffic jam and all that is above 80. So WHO recommends a noise level of not more than 55 decibel in order to have peace of mind lah. Okay, that means your health is not affected, around 55, 50 to 60 lah. Now, what are the effects of noise pollution? First of all, it damages your ears. You may have hearing problem. Your you call the eardrum. Okay, very loud noise, extreme loud noise can puncture your eardrum. Okay, so that causes deafness. Okay, very, very loud noise. And headaches, some people will have migraine or headache when you hear loud noise. It's like mentally you're affected. So you may even you may even have a headache. Emotional mental disturbances, yes. Okay, sometimes you cannot concentrate, you cannot think because too loud noise. Then it's also psychosomatic. Sometimes your mental health can affect your body. So because you're not emotionally disturbed mentally, you find you have heartbeat increasing, or you feel irritated, you feel very young, you feel very irritated, and you feel worrying and all disturbed. You have respiration also increases. You may even have high blood pressure increases. So all this affects your body. Just like when you get angry, actually when you want to scold people, when you're angry, you find your heartbeat increases. So your mental health actually affects your body. And of course, the worst is loss of hearing because of deafness lah. Okay, and sometimes it could be a gradual. In fact, it always gradual. Usually gradual time, and also because of effect on you will find that your sense of hearing is not so sensitive. Okay, where are the sources of noise pollution? Where do you get all these noise? So usually aircraft, jet planes, taking off. Okay, so people who direct traffic of the aeroplane coming in, and they have earmuff. Okay, they have to wear the earmuff so that they cover their ears and they block out the loud sound. Trains, right? Machinery, okay, construction sites, when you dig up the road, you have those machines that go do, very, very loud and very uncomfortable. That can also affect your hearing. Machines and wheels, equipment in factories is very, very loud in factories. And traffic jams, yes, this is also very bad, especially people honking. People honk is very noisy. So you can see here, very low is about 100. Anything else you can have what we call damage your eardrums, and you can go deaf. Okay, so the safe one is about 60. Okay, anything below that is very safe. Okay, so lastly, let's talk about human population growth explosion. Okay, this is another part. Pollution we're done with. We look at the last part here. So pollution, human population growth explosion, you find that over time, okay, over hundreds of centuries. In fact, we look at many centuries ago, you don't even achieve 1 billion. This is talking about billion. Okay, we only started reaching more than 1 billion at the year around 19th century. And then slowly now the world population is now approaching, it's about 7 point something billion, 7.8 billion, I think about 8 billion. Okay, and the next 20 years, these are going to go to 9 billion already. So the approach, the increase is actually not linear. You find that this graph is not linear. It suddenly shoots up. So we call this graph exponential graph. I'm sure you learned it in maths. Okay, when you have your graph, it goes up like this. This is called exponential. If this is called proportional. Okay, every rate is a straight line like this is called proportional. But when your graph curves steeply, this is called exponential. And for human population, if you plot the graph here, it's definitely exponential. That means the rate does not increase the same every year. Suddenly, there is an explosion. That's why we call it explosion. Why? Okay, why suddenly after the 18 something 19th century, why suddenly humans have become so many? Okay, there are a lot of factors. Right, number one, we live longer now. Okay, so the people who are born also share the same what they call the existence with the people who are not dead yet. So people, now the livelihood, the lifespan has increased to more than 80 in Japan. Okay, in certain society, there are a lot of old people, 65 to 80. Okay, age. I just read, I seen a documentary not long ago that is the population of Japan now. The old people actually is very high. It's about almost 1/4 of those in Japan. The population from age 65 and above. So can you imagine that 1/4 of the population is already 65 years old? That means the 3/4 is 65 and below. The young people are less, but the old people are getting more and more. Okay, so there's an imbalance there. Why? Because they live longer, they generally live longer. Okay, why? Because of better medical facilities. People now don't die so early because you have medicine. And whenever anybody has got any illness, you can go to the hospital and you get cured. So you have medicine, you have vaccination. It helps to prolong life. Increased birth rate. Certain countries have got very high birth rate. For example, in Africa, a lot of countries here, you have the population of young people far exceeds the population of old people. Old people die early because of the hospital facilities are less, they have less medicine and so on. But young ones are being born. Okay, the babies are born very, very quickly. Number one, maybe because of lack of education, right? They don't have high level, so they do not know about maybe contraceptives and prevention of birth and so on. So they feel women, maybe they feel in their society, in their culture, they feel it's their job to produce. So they keep on producing without any stop. So that's why you have a high rate of birth rates in usually lower developed countries. Okay, for those who are very developed countries, lower birth rates. Okay, and then low death rates also due because of the fact that the lifespan has increased. So nowadays, the lifespan generates about 70 over years for the general population of the world. In Japan, it goes up to a bit higher, almost 80. Okay, so as population increases, why is it bad for the environment? Why the population of the explosion is bad for the environment? How is it affecting our world? Okay, it affects our world because if more people you have, you got to grow more food, correct? You got to make more houses. There is a need for better facilities. You got to make facilities. You got new houses. You got to increase your hospitals, medical supplies. You have to increase your more food. You got to grow more food, and you also have a use for more fuel. Okay, so humans, the number of people increases, you need to provide more food for them, otherwise they will die. Okay, and then you need to have more use for energy, people using more electricity when there's more people also producing more waste. That is even worse. Okay, because you have more garbage. More humans means more garbage. Okay, so this is a threat to the environment because more garbage means you are dirtying the environment, you're polluting the environment. Okay, so deforestation is one of the major effects of increase. Because you have increase in population, you got to cut down more trees. You got to cut down more trees. You got to build new roads. You got to build new houses. So you got to cut down more trees. Okay, so that will decrease the number of plants, and that of course will increase carbon dioxide emission. Okay, you will result in species extinction when you cut down trees. Some animals don't have the tree to stay anymore. You will increase global warming, you make it worse. there's also shortage of water and food supplies, okay, because you cut down trees. So in order to reduce the negative impacts, every government must know how to control. It depends on every government how you want to, your government, your policies, government policies, how you want to control your population. Okay, do you want to give incentives to people? For example, people who are not producing, they're not having children, do you want to give incentive? Okay, or what do you want to do with the old population? Okay, you have to control and manage how do you want to decrease the birth rate if the country is a lot of people are producing or having a high birth rate? How do you want to control it? Okay, impacts means the effect on the environment. Okay, so you can see all this here. Global warming, right? Why global warming? Because you cut down trees, you will have more carbon dioxide. That increases global warming, climate change. Okay, land and soil degradation. You excessive use of soil because of farming. You put fertilizer, improving food supply. You may have eutrophication also. You put too much fertilizer, you will cause eutrophication. Okay, then soil erosion. All right, it reduces the fertility of the soil. Okay, because you cut down trees and so on. Next, depletion of natural resources like petrol, minerals, petroleum, coal. They are going to be used up. So you're going to look into alternative sources. Okay, because all these are non-renewable. You're going to use up your resources quite fast if you have more people. Next one, pollution, excessive use of fertilizers and pesticides to increase crop production. You need to make your food faster. You got to grow your food faster, so you put in more budget, okay, put in more fertilizer, and that's pesticide, and that is going to cause water pollution when it runs into the lakes. Industrialization, all right, increases the waste. Yes, more human, more waste. Okay, causes more pollution. And lastly, degradation of ecosystem. You find that the large population will cause many problems to the land aquatic system. You'll be destroyed. Okay, loss of biodiversity. Finally, some plants will die. Okay, some animals will die, and also will lead to extinction of species. Okay, so ultimately you'll find that some species will be gone. You will never see anymore because their rate of reproduction is low and they keep dying. Okay, because of certain factors in the environment. Okay, so this is what I want to cover today. All right, I've already covered pollution and the human population explosion. All right, okay, so I hope that you can understand this, and you can always test yourself by doing questions. Testing is always very good. Doing questions is always the best way to test whether you understand something or not. Okay, so I will stop here, and I will see you in Google Meet afterwards, so we can do questions. And you have further questions, I can discuss that. Okay, so at the moment we will say bye-bye. All right, thank you for watching, those out there. Okay, I'll see you in my next lesson, which could be on Saturday again. Okay, right, bye-bye.